Let's continue investigating exponents. Now we're going to explore a squared raised to the power of 3. Well, again, going back to the definition of exponents, we need to be able to recognize the base and the exponent. In this case, the exponent is 3, and it's touching the parenthesis, which means whatever is inside is the base. So in this case, our base is a squared, and it will be repeated 3 times. So we can write it as a squared times a squared times a squared. Now, with that, again, I really want to understand this. Well, what does a squared mean? Well, in each set, a squared really means a times a times a times a times a times a. Now, that's 3 different groups of these values, but what we notice is all the values are multiplying, so there is no need for the parentheses. And so if I remove the parentheses, what I have is a times a times a times a times a times a. And because it's the same value being repeated in terms of multiplication, we can use exponents. In this case, our base would be a, and it is repeated how many times? 6. So another way to evaluate a squared raised to the power of 3 is a to the 6th. Now let's look at another example. In this case, we're going to look at an instance that involves numbers. 3 to the 4th raised to the power of 3. Well, again, the exponent is the outside value. In this case, that's the 3. And it is linked to the base, whatever's inside the parentheses, which in this case is 3 to the 4th, which means the base is repeated. So 3 to the 4th times 3 to the 4th times 3 to the 4th. Because again, the base is repeated as many times as the exponent. But in this case, 3 to the 4th, what does that really mean? Well, 3 to the 4th is really 3 times 3 times 3 times 3. That was the first one. Times another set. Times 3 times 3 times 3 times 3. Times another set. Times 3 times 3 times 3 times 3. That's really what is going on behind the scenes. And again, parentheses are not necessary because this is repeated multiplication. We can list out all these 3's. However, you may notice it's not the best use of your time to always expand this out. Instead, we can use exponents to write it a little quicker. Because 3 is being repeated, that would be our base, and it was repeated how many times? Well, it's listed out 12 times. Now take a moment to see if there's an easier or quicker way to go from the original problem to the simplified exponent answer. Pause the video now. Hopefully you noticed that the exponents can multiply would give us the result in our answer. And that brings us to the next rule. This is known as the power rule for exponents. It states if m and n are positive integers and a is a real number, then a to the power of m raised to the power of n equals a to the power of m times n. In other words, keep the base and you multiply your exponents. Use the power rule to simplify each expression. For a, we have open parentheses, 9 to the 4th, close parentheses, raised to the power of 10. In this case, what you will notice is our exponents are touching. And when your exponents are touching, this is the only time your exponents may multiply. And so we can write this using the power rule. We keep our base and we multiply our exponents. So 9 raised to the power of 4 times 10, which we can simplify and write 9 to the power of 40. Example B, we have open parentheses, x to the power of 6, close parentheses, raised to the power of 5. Again, using the power rule, we notice our exponents are side by side. They are touching. Again, this is the only time you are allowed to multiply your exponents. So to show our work and take good notes, we write it as x to the power of 6 times 5, which simplifies to x to the power of 30.